The second type of transformation that we will talk about is called a reflection. And a reflection is just a flip over a line. Every point is the same distance from that line, and it is the same size, so therefore the image and the pre-image are congruent, they're the same size. The line that the object flips over is the line that's right in the middle of the pre-image and the image is called the mirror line. So when you think of a reflection, you look into the mirror and you need to see itself, but it's backwards. So for our first example, we want to reflect the pre-image over the x-axis. So the x-axis is the vertical, the horizontal axis. So to do the reflection, you need to figure out how far each point it is from that line. Then we're going to go that same amount of distance on the other side of the line. So if we want to do A first, if we go from our line and count to A, we are 1, 2, 3, 4 points above it. So therefore, to do A prime, I want to go 4 points below that line. 1, 2, 3, 4. And put a point. Alright, so then to do B prime, I need to figure out how far away it is from the line. It is 2 points above, so I want to go on the other side of the line now. I want to go 2 points below and put a point. And then for C prime, C is 2 above, so to do C prime, I want to go 2 below. Then I can connect my dots. This would be B prime, this would be C prime, A prime, and that is the reflected image. Now I also wanted to find the coordinates of the reflected image. So my coordinates of A prime is, I want to go to the right, 1, 2, 3. So my x coordinate is 3. Then I went down 4. 1, 2, 3, 4 to end up at that point. So my A prime image is 3, coordinate is 3, negative 4. To do B prime, I go to the right 1, down 2, so that would be 1, negative 2. To do C prime, I want to the right 1, 2, 3, 4, 5, and down 2, so 5, negative 2. Now like we did for translations, we want to write a general formula, or general notation for a reflection. So if you reflect over the x-axis, let's look at what changed. All right, in my image A, or pre-image, A is 3, and A prime, it is still 3. So my x, when you reflect over the x-axis, your x-coordinate does not change. But my y-axis went from 4 to negative 4. So you want to take the opposite sign of whatever your pre-image is. So to write that in general form, it is just negative y. So that tells you to do the opposite of whatever y is. That works for the x-axis only. Okay. So if you reflect over the x-axis to get your points, you do your same x-coordinate, the opposite sign of your y-coordinate. Go ahead and pause the video to do you try by yourself. Alright, so to reflect over the y-axis is your vertical one. You want to see how far away each point is from that axis. So if we want to do A prime first, it is 1, 2, 3 away on the left-hand side. So I need to put it 3 away on the right-hand side. Alright, so to do B prime, it is 5 away on the left-hand side, so I want to go to the right 5. And then same for C, it's 5 to the left, I want to go 5 to the right. That gives me my 3 points. I need to connect them. Give you my A prime, B prime, and C prime. And then to write the coordinates down, to get A prime, I go to the right 1, 2, 3, and up 3. So my coordinate would be 3, 3. For B prime, I go to the right 5 and up 5. And for C prime, I go to the right 1 and up 1. general notation for reflection over the y-axis. Let's look at our original compared to the new ones. So A prime I want from -3 to +3. So opposite signs, same number but different signs. So therefore I want to do the -x, and then to look at the y-coordinate. And A it was 3, and A prime it stayed 3, so the y doesn't change at all. So general notation. So when you reflect about the y-axis, you're just going to change the sign of your x-coordinate. The y-coordinate is going to stay exactly the same. Change the sign of your x-coordinate. That's only true for when you're doing over the y-axis. Remember before, over on the x-axis, the x stay the same, but you change the y sign of the y-coordinate. So just be careful on what you're reflecting over.